Well, pre-calculus classes, as always, good morning, good afternoon, or good evening. We are going to finish up P.7 here today, solving absolute value equations, and probably the best news is this is by far and away the shortest of all of the parts. So, again, I know last year in Algebra 2 you guys looked at solving absolute value equations, so this should mostly be a review. The only thing that may not have been something you did look at is, you may not have had quadratic absolute value equations going back to Algebra 2, but, the process shouldn't be anything that is new. But when you solve an equation involving absolute value, you do have to use two separate equations because absolute value makes everything positive. So when you have the absolute value of x minus 2 equals 7, you can have an answer in here that, if it's positive, will make it equal 7. But if your answer, or whatever's inside your absolute value, is negative 7, remember that turns it into positive 7. I'm guessing somewhere along the way you had a teacher that talked with you that absolute value represents a distance from 0. So when we solve this, we're going to solve both x minus 2 equals 7 and x minus 2 equals negative 7. So when you add the 2 for this one answer is x is 9. Add the 2 for this one, the other answer is negative 5. And again, for this one, you don't really need to check for extraneous. Plug the 9 in, 9 minus 2 is 7. Absolute value keeps a positive the same. If you plug negative 5 back in, the absolute value of negative 7 becomes positive. So these both work. Now, for example 2, this is where we are going to definitely have to check for extraneous solutions. Again, much like with radicals, if you have a variable outside of an absolute value, there is a very good chance you will end up with extraneous solutions. So what we're going to do, x squared minus 3x, set it equal to 4x plus 6. We are going to have a second equation where you take the opposite of both. You can certainly take the opposite of this side instead. I usually leave the side with the absolute value as is. You just change one of the two sides. So from here, what we're going to need to do, add the 4x, subtract the 6. So x squared plus x minus 6 equals 0. And then we'll factor. Well, what multiplies to negative 6 adds to 1. That will be 3 and negative 2. So x is negative 3. X is positive 2. I'm going to hold off on checking for extraneous until the very end for all of these. For this one, subtract 4x, add the 6. So x squared minus 7x plus 6 equals 0. Now again, we'll factor. What multiplies to 6 adds to negative 7, negative 6, and negative 1. So x minus 6, x minus 1 equals 0. So our two solutions are 6 and 1. Now, yes, you do have a little bit more to check. So when we plug negative 3 in, that's 9 plus 9, so 18 equals 18, so the negative 3 works. When we plug 2 in, 4 minus 6, absolute value makes it 2, negative 8, so that one is extraneous. When we plug 6 in, 36 minus 18, so 18 equals negative 20, negative 18, so the 6 does not work. And then when you plug the 1 in, you get 2 and 2. So negative 3 and 1 are our two solutions. really you can see the key is if you plug in the answer, if you get a negative on the non-absolute value side, that's what's going to give you your extraneous solution. So where you, again, can end up with extraneous solutions, absolute values, radicals, rational equations, with everything that we have looked at to this point. So, again, that wraps up P.7. As I said, this third day was going to be much shorter than the first two.